The importance of the Kelvin temperature scale in scientific research.
Science Makes Me Smile, presented by young Dr. JGC, a creation of old Dr. JGC.
If 1 Kelvin is equal in size to 1 degree Celsius, why do scientists still use the Kelvin scale?
I am young Dr. JGC. Let's begin.
To understand why the Kelvin scale is such an essential tool in science, especially in physics and chemistry, we must first understand the true meaning of temperature. When we measure the temperature of a substance or object, what we are really measuring is the amount of motion or vibration of the molecules within that substance. The faster the molecules move, the higher the temperature. The slower they move, the lower the temperature. This idea is key to understanding the fundamental difference between the Kelvin scale and the Celsius scale. When measuring temperature in degrees Celsius, one might naturally assume, based on the definition of temperature as the degree of motion of molecules or particles within a substance, that at 0 degrees Celsius, there would be little or no molecular motion at all. In reality, however, there is still an intense amount of activity taking place inside the substance. Even in ice at 0 degrees Celsius, the molecules are vibrating vigorously. In a microscopic sense, there is still a small storm occurring within the material. The reason for this apparent contradiction is that the Celsius scale was not designed around the true energy state of matter. Instead, it was built on arbitrary reference points based on the behavior of water. The temperature at which water freezes was assigned the value of 0 degrees Celsius, while the temperature at which water boils was assigned 100 degrees Celsius. These values are convenient for everyday life, but they do not directly represent the actual amount of molecular motion or thermal energy within a substance. Because of this, the Celsius scale is practical for ordinary use but limited in scientific meaning. The Kelvin scale, by contrast, begins at absolute zero, the theoretical point at which molecular motion reaches its minimum possible level. As a result, Kelvin provides a true physical measure of temperature, making it far more meaningful and indispensable in physics, chemistry, and thermodynamics. A temperature of 80 K corresponds to exactly twice the amount of molecular motion and thermal energy as 40 K, because the Kelvin scale begins at absolute zero. In this sense, 80 K truly has double the thermal effect of 40 K. By contrast, 80 degrees Celsius does not correspond to twice the molecular motion or thermal energy of 40 degrees Celsius. Since the Celsius scale does not begin at absolute zero, its numbers cannot be compared directly in this way. This slide combines both temperature scales. Notice that at 0 degrees Celsius, the molecules inside the substance being measured are still vibrating intensely and are far from being at rest. This is not the case on the Kelvin scale, where 0 Kelvin corresponds to the minimum possible molecular motion. When scientists think of temperature in its true physical sense, as a measure of molecular motion, energy, and disorder within a substance, the Kelvin scale becomes the only truly appropriate scale for scientific work. To determine the true level of molecular motion, the Celsius temperatures must first be converted to Kelvin. When we compare these actual thermal values, expressed by Kelvin temperature, we find that 80 degrees Celsius does not double the molecular motion of 40 degrees Celsius. Instead, as these numbers indicate, 313 to 353, the increase is relatively modest.
Now we can clearly understand why, although 1 Kelvin is equal in size to 1 degree Celsius, the Kelvin and Celsius scales are not in the same league scientifically. Fascinating, isn't it?
Thank you for watching. Let us know what you think about this episode. Please share and subscribe.